Hi everyone, this is Muhammad Aloush and I'm introducing you to the open source MATLAB package uFVM. uFVM is a open source CFD tool oriented towards learning the basics of CFD and in particular the finite volume method. I put this package in your hands and I hope it helps those who are seeking to learn CFD to make use of this package. It is really designed in a very good and clear way so as those who are taking a look into the code will easily track the functions and know how things are designed, how the algorithms are made, and how are the problems solved. So this is the first session for uFVM and providing you today with a quick tutorial on how to use it. So let's start, and I'm currently in the main directory of uFVM. Once you download it, whether from the website of the CFD group at the American University of Beirut or the MathWorks file exchange community, you can find it there as well. And you can find, of course, the link below the video on YouTube. So whenever you download it and extract it, please get inside uFVM, the main directory, which includes resources, tutorials, other functions and utilities. And of course, it contains a quick guide. This is a small PDF where you can follow up and know exactly how to use uFVM. So first of all, get into this directory. I'll go into one of the tutorials and make it in front of you. Let's go to incompressible, and notice, guys, that the way I'll get into the elbow tutorial. Notice that the way we deal with the user data input is the same as we do for OpenFOAM. Those who are interested, more than that, they can go and read about OpenFOAM files and how do we prepare cases and stuff. And those who already know about that, they already know that there should be these three main folders. The zero directory, which contains the initial conditions and the boundary conditions of the fields. The transport fields, particularly. The constant directory, which contains the mesh, if you can see here, and contains other files that include the properties of the fluid and turbulence properties as well. The system folder contains some files which include the solution methods, the schemes of discretization, and the timing of the solution. So the time step, the starting time, the ending time, and some controls overwriting the solution fields. So again, those who already know OpenFOAM should be familiar with that. And you can go and open guides on whether OpenFOAM website or other reference or source, and you can find in details how to prepare these files. And I'll not go deeply into that for the time being. So here's one of the tutorials in the incompressible category. It's an elbow case, so whenever you go into a case, you can find these OpenFOAM folders. In addition to this run file, actually you can run the tutorial from this file here. You can see that there are a set of commands, small, brief definition of what we are simulating. So it's a water flow in an elbow. So, and you can find that there is this function. Here's a function where we initialize the database. The database is expected to store all sorts of information, the fields, the mesh, the solution methods, and other stuff. Here is the place where we read the OpenFOAM files, the zero, the constant, and the system. And here is the place where we define the equations, the momentum equation, for example, the continuity equation. So as you know, for a general fluid flow problem, you need to solve these two equations, the momentum, which is the Navier-Stokes equation, along with the continuity equation, which turns into a pressure equation as dictated by a pressure-based method. And here is the function where we call the solution or the solver of these two equations. So we are currently in the elbow case. Let's try first to check the mesh. You can simply put and let me first tell something that whenever you want to use uFVM, you have to add the path of the uFVM sources to your current directory in order for you to use it. So please don't forget to go to Home tab, Set Path, and subfolders, and go back please to the main uFVM directory, which is this one, the directory which contains the sources and utilities, and select it. You can save it for later use if you want. Currently, I'll not do it. So now if I want to check this mesh, I can simply type in CFD check mesh, and you will see that this mesh contains these properties. For example, this mesh contains 9, 18 cells and 3,290 faces, etc. There are, of course, additional information related to that geometry. So you can also plot this mesh as well by typing in CFD plot mesh. And here's the mesh, here's the elbow case. Let's go to the XY view, and you can see here's an inlet. There's an inlet right here. Here's another inlet. And here's an outlet. And these are walls. This is a wall, 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 and wall. So this is our mesh. Now we are going to run it. Let's take a quick look on the boundary conditions of the velocity. So we have two inlets. One of them is 100, the other one is 030. For the walls, we have no slip. For the outlet, zero gradient. And of course, we have front and back planes because this is a pseudo 3D mesh. So this is for the velocity. For the pressure, let's take a look into that. So zero gradient on the walls, zero gradient on the inlet. For the outlet, the pressure is fixed at 0 pascals. And I'll not take a look into the other stuff related to the files. You can do it yourself. I will now run the case by typing CFD run. You can see what's going on. It's printing some stuff and starting to print the residuals information, and here is the plot of the residuals. So the residuals are getting plotted during solving of the equations. So it's progressing the solution of the problem. I think I'll stop right here because I think the solution is almost ready. So I'll stop, I'll press Ctrl C, and now in order to visualize the results, you can type in CFD post, post processing, and this is a nice small GUI in which you can visualize the fields. And notice here that we have now solutions at these time steps. So control over writing the solutions is of course dictated inside the control dict file located in the system directory. So now this is our nice small GUI. You can find initial of the mesh right here. Let's put that in the middle. Now this is the mesh. You can select the field that you wanna visualize. Let's say I'll keep for the time being the U. You have of course other fields like pressure, conductivity, specific heat, viscosity, and density, etc. I'll keep on the velocity field. Let's try to plot the contour of velocity at the centroid with the mesh lines shown. And here is the update of the graphics window. If you press on that, notice that we're still at time 0. We can go to the final time step, and here's the final time step. Let's zoom a little bit. Okay, you can see now. Let's remove the mesh lines. Okay guys, so you can see that there's kind of mixing in here and stuff is going on. Let's turn into a node value. So now the field, which is located basically at the centroids of each of the elements. So these elements, we have now the velocity field located at the centroid of each of them. When you choose the node value, now these centroidal fields get interpolated to the nodes, giving rise to smoother fields. Let's see what happens now. Okay, you can see now it's smoother, nicer. You can also plot the velocity vectors. Here are the velocity vectors. As you can see, you can increase their scale. If you're not able to see them, you can play with the opacity of the contours in order to make the vectors more bold, if we can say. Yeah, and there are some other stuff here related to the mesh preview. You can visualize certain elements if you want. So the post processor will give you the number of elements existing in this mesh, the number of faces. You can visualize any element of interest or face of interest, or even the patch of interest. If you want to see patch number 1, which is, for example, the wall, you can see it here in this place. So that's a quick review on how to use uFVM. I'll get out of that and hope this makes a brief yet good insight into using uFVM. And please let me hear from you. Use the email that I'm providing along with the link of the sources below the video on YouTube. I want to hear from you the feedback. and we'll meet again maybe in another video. Bye bye.